5.3 talks about improper integrals. And that just means it's a definite integral that has a limit at infinity. For instance, if we're going from minus infinity to 0, for e to the, let's say, minus 4x, then what you're really doing is taking the limit as something goes to minus infinity of the integral from that something to 0. This is the technical way to do it. You'll see that I usually skip this step because we're smart enough to figure it out at this point. So when I integrate e to the minus 4x, I get e to the minus 4x divided by minus 4. And I'm going to evaluate that from minus infinity to 0. So I plug in the top number first, minus the bottom number, and that power is going to be minus a negative infinity. So this piece right here, e to the 0 is 1. So I'm just going to get minus 1 over 4. Next term, minus a negative is plus. But e to the infinite power is infinity. So your book, the way the book teaches it, you say it diverges. That just means it blows up and goes forever. I believe that writing that it's infinity gives more information. So now let's do an example where you can actually figure things out. Same integral from 0 to infinity. Well, we went from minus infinity to 0. Let's go from 0 to infinity, e to the minus 4x dx. So when we integrate, we copy the e to the power, divide by the minus 4, evaluated from 0 to infinity. Now, writing it down, I know this is supposed to be the limit if something goes to infinity, but we're smart enough to figure it out. Plugging in the 0, I get e to the 0. Okay, let's think about what this means. I have a constant. It's raised to a negative, very large power. That means it's going to be a positive, very large power on the bottom, right? This thing is going to go to 0. Minus a negative, e to the 0 is 1 over 4, and we get 1/4 for our answer. Okay, let's do another one. Try 0 to infinity 3x over x squared plus 4. What kind of integral is that? Well, you have a denominator with no power. So when you look at that, you think, first thing you should do is think, this is a logarithm. Is the derivative of this in the problem? Well, you have the x and the dx. So all we need is a 2. So I'm going to rewrite, the 3's in the way. X squared plus 4. Here's my dx, here's my x, and I need a 2. And that's going to give me 3/2 ln of x squared plus 4. And this is going to blow up again. From 0 to infinity, you get 3/2 ln of infinity, which is infinite, minus 3/2 ln of 4, which is just a number. So this diverges. Okay. Try this one. We're using the same u and du as substitution. We've got blob to the minus 2 We have an x and a dx, but the derivative of the blob is 2x, so we multiply by the 2. Here we go, straight power rule. Add 1 to the power, divide by the new power, simplify it, 3 and a negative and a 2 and a blob on the bottom. Evaluated from 0 to infinity. Now, when we plug the infinity in, we get it on the bottom. Negative 3 over an infinite value is 0, minus negative 3, 2 times plugging in the 0, I get a 4, minus a negative is plus, and I get 3/8. I know most of you have to take probability in your business stats class, and most of us have studied a little bit of statistics, probability, and we've heard of a normal distribution, which let me see if I can find a picture here. Found one. Okay. This curve represents what we're used to seeing as a normal distribution. The red one that's flat represents a large standard deviation, whereas the tall, skinny one has a very small standard deviation. Usually, if you're talking about normally distributed data, you get this blue one. But not all probability density functions are like that. If you were waiting at my kid's dentist, then your curve is going to look like that. If you're waiting at the eye doctor, it's going to look like this. Okay? So that some are skewed to one side or the other. Some are even like this, where the probability for an outcome at the beginning would be high, whereas as time goes on, your probability goes down. The point of it, what makes these all probability density functions, is that the area under the curve over the whole interval the area is 100% because it's the sum of all the probabilities of all the possible outcomes, and it should be 100%, so the area should equal exactly 1. And a lot of the time you're going to end up with density functions that look like this. Say, what's the probability of finding bacteria in the pond if eradication measures were started at the beginning? You would see the probability would go down over time, for instance. So, like I said, for something to be a proper probability density function, then the integral from 0 to, or let's say from a to b, whatever the interval is, of that function equals 1. So you can have something like find k such that, let's say, ke to the minus 3x is a proper probability density function. Your book doesn't say proper, does it? Find k such that that function is a probability density function on the interval 0 to infinity. So what you would do is integrate from 0 to infinity ke to the minus 3x dx. You integrate and evaluate. When you plug in the infinity, it's e to the negative infinity, so you get 0, minus the k on top, a 3 and a negative, and plugging in the 0 here, e to the 0 equals 1. Minus the negative is plus, and that's the integral of that function. But for it to be proper probability density function, it has to equal 1, and you find that k has to equal 3. So that's one use for it. K equaled 3. If you know that e to the minus 3x, because k equaled 3, there we go. If you know that 3e to the minus 3x is a PDF, then you can find the probability using that function. What is the probability that whatever you're looking for will be let's say from 1 to 2. Simple enough, right? Now you can take that function because you know it's proper. I messed that up. K is the 3, isn't it? You know that it's a proper probability density function. So you can integrate on any subinterval and find the probability that your outcome will be between the 1 and the 2. So integrate and evaluate. And we're going to get some nasty numbers. Minus e to the minus 6 minus negative e to the negative 3. And if you plug this in your calculator, you're just going to get a number, a nasty number that goes on forever and ever. So we're going to say that this is 5.23%. That's the probability on that probability density function that your outcome will happen between 1 and 2. If you want to do this from between 0 and 1, for instance, integration is the same. Evaluate from 0 to 1, you're going to get minus e to the minus 3 minus negative e to the 0. So that's minus e to the minus 3 plus 1. And you get 0.95 and a bunch of other numbers. So that's 95% probability that your answer lies between 0 and 1.